Calm down, everyone. Let's start off. Great. Let's go ahead with the problem. And get uploaded. Let's get this. In steady state. So, in steady state, capacitors will become like open circuits. So, look at this. So, current won't flow through the circuits. Getting it? So, these resistors are useless. This is point A. This is also A. This is also A. This is B. This is B. Let's call this thing C. So this is C and this is C. So even though it looks like there are a lot of points, in reality there are only 3 points here. So we have A, B, and C. So the 3 microfarad and the 3 microfarad are between A and B. So this is 3 and this is 3. And between A and C there is one more. And between B and C there are two more. 1 microfarad and 1 microfarad. And this is 1 microfarad. Getting it? This is your thing there. This is 1 microfarad and there the battery is here. He's asking potential difference A and B. I think now you can solve it, isn't it? So these are in parallel. So basically, this 1 microfarad also you can keep it outside. It won't matter. Then this 3 and 3 will become 6 and that will become 2. So potential will divide in the ratio of Q is equal to CV. So potential will divide in the ratio of 1 by C. C2 is to C1. You'll get it from there. Is that clear, everyone? So VAB by VBC will be in the ratio of 2 is to 6. And the total voltage is 100. Clear with this? That's a HCV question. It's a decent one. This was a good one. This second question, right? I'll change the question also. Instead of saying with this thing, arrange these four in descending order. Meaning which the ammeter of 10, ammeter of 5, voltmeter of 5, voltmeter 10, which will have the biggest resistance, which will have the smallest resistance. Arrange them in the descending order of resistance. This is a pretty good one. The first one is like a pretty standard one, like a CET level question. What about the first one? Now, you want to apply Ohm's law, we need resistance is equal to V by I. So you need to measure the voltage and the current. Voltmeter must be placed in parallel and ammeter must be placed in series. The option. That is the only idea there. So voltmeter must be in parallel so that you get the same voltage, and ammeter must be in series. What about this thing? If you guys remember, how do you construct an ammeter? By putting a shunt resistance in parallel. And smaller the resistance, better the range, isn't it? So for ammeters, smaller the resistance, better the range. For voltmeters, bigger the resistance, better the range. In case you have a doubt on that, you should definitely go to the current electricity notes and you should go through the theory once. Because in ammeters, when you shunt it, resistance decreases actually. For ammeters, lesser the resistance, more the range. For voltmeters, the resistance is placed in series. So larger the resistance, more range. So one thing is clear, ammeters will have more resistance than ammeters. So between the two voltmeters, the 10 volt is the biggest guy, so D is greater than B. And between the two ammeters, 10 is the maximum range, so that must be the least resistance, C and A. Is that clear, everyone? That's a good one, last one. So be careful with that. So the two voltmeters will be greater than ammeters. Ammeters are smallest. Between the two ammeters, 10 is even the smallest because more range means lesser resistance. So in this, there is one more model of question. If you remember, we have a resistor, we have an ammeter, and we have a voltmeter. Right? The voltmeter shows 5 volts. Ammeter ka reading is, let's say, 1 ampere. And both are non-ideal. Then they have some resistance with them. So in both the cases, what is the resistance? Options will be R is equal to 5, less than 5, greater than 5, can't say, ऐसा कुछ options होगा. No. These are non-ideal. Tanvi, I'm asking the resistance of the device only. There is no external resistance here. Here we are comparing resistance of the ammeter, resistance of the voltmeter. You are comparing the resistance of the device. You're not keeping something in parallel or series. What is an ammeter? A galvanometer plus shunt resistance together is called an ammeter. Don't get confused between galvanometer and ammeter. You construct everything from galvanometers. Galvanometer is the fundamental unit. What about this thing, everyone? So again, another good theoretical one. Both are non-ideal. What will be the reading of resistance in both the cases? See, this is showing 5 volt across the resistance. So this is actually correct, right? When this is showing 1 ampere, in reality, this must be, if this current is some IV, this is I, you're getting it. So in the first case, resistance R1, I'll call it R1 here. What is the resistance when we say V by R? What is that? That is a voltage across the resistor by current in the resistor. This will be 5 and this will be something like 1 minus IV, isn't it? This will be 1 minus IV, means the current will be slightly less than 1. All the current is not flowing through the resistance, isn't it? So this is actually greater than 5 ohms. In the second case, they will have the same current. So when you say this is 1 ampere, this is also 1 ampere. But when you say this is 5 volt, so the voltage across the resistance will be 5 minus resistance of voltage of the ammeter. So this is the resistance of the VR plus VA combination. Are you getting it? So in this case, the resistance, let's call it R2, will be the voltage is 5 minus VA by current is right. So this will be less than 5. If this had been ideal, it wouldn't have mattered. You would have got the same answer. In case of a non-ideal, the answers will be, there will be an error. This is the reason why you use a meta bridge. When you want to find the resistance, why don't you just use an ammeter and voltmeter and finish it off? Because you'll always get an error. In case of a meta bridge, you will eliminate this error. Clear with this? Let's see one more on instruments. Look at the first one. A galvanometer coil has a resistance of 90 ohms. So this is your RG. Full scale deflection of current 10 milliampere. So this is the maximum current you can send. This is IG. And 910 ohm is connected in series. So this is your R large. You want to make this into a voltmeter. So the formula for this thing is what? V is equal to IG R galvanometer plus R large. That's the formula. So done, directly substitute there. That would be 10 power minus 2 and this would be 1000. 910 plus this. So this is 10 volt. And now you're saying you have least count of the voltmeter is 0.1 volt. So number of divisions will be 10 volt is there. So if each division is 0.1 volt, then 10 volts will have 100 divisions. That was easy. What about this guy? The ammeter is showing a 0.1 ampere. The ammeter ka voltage is 20 ohms. Voltmeter is showing 12 volt. So voltage across the resistance plus voltage across the ammeter must be 12. This is 0.1 into R and this guy must be 0.1 into 20 is equal to 10. R is equal to 100. Easy? Check it out. Easy stuff, but these questions are important. Any doubts on this? Let's get this. This is based on potentiometer. Like I said, we will do few questions. Advanced में तो है, bits में तो है. Mains में they did remove. This is still an easy one. So potentiometer is useful to measure unknown EMF of a battery and internal resistance of a battery. Understand what each instrument does. Ammeter measures current, voltmeter measures voltage, meter bridge will measure resistance, potentiometer measures battery ka unknown EMF of a battery and internal resistance of a battery. So you should know which device measures what. And I'm not sure why the hell they removed this. Quite an important thing and useful thing. So, but okay. Until unless we get the new advanced portion, advanced ke liye to hai. And if you remember, when I taught you this, there's only one concept here. You want to get zero deflection in the galvanometer. So just redraw the circuit. So if you want zero deflection in the galvanometer, meaning there is no current here. That means the current in this branch is completely zero. So if this is E and this is R, let's call this point as A, and let's call this point as C, then let's call this point as A dash, and let's call this point as C dash. You can clearly see A and A dash are actually same. VA is equal to VA dash, they're connected. And VC is equal to VC dash because current is zero. Since current is zero, potential difference across must be gone. This is the whole concept of potentiometer, if you remember. Whenever the bridge gets balanced or the galvanometer current becomes zero, this potential difference will be always equal to this potential difference. That is the whole concept of potentiometer. And then you're done. So there's no current in the bottom circuit. So all the current is flowing only in the upper thing, the primary circuit. This is capital I. I is equal to E by that is 15R and this is small r. So that is total 16R. So what is the potential difference across IAC? Capital I into resistance of AC. What is the voltage across A dash C dash? that will be E by 2 minus IG R, but IG is 0. So this term is gone. So this is E by 16R, and RAC will be how much? Total resistance 15R by length of the wire L. E will cancel on both the sides. What do you want to find? Length, na? So let this length be X. I'll just keep it as E by 15R by 2 into AC. That is what you're trying to find. So AC will be E cos of, we'll get L by 15 into 8. L is how much? 1600. That is 15, 448, 320 centimeters. Clear with that? Again, if you see now, even though we are calling it potentiometer, if you actually understand what is there, it is simply current electricity equation, isn't it? Since the current in the galvanometer is 0, this potential difference must be E by 2. Are you clear with that? Let's get this. This is a good one. Easy one, but little conceptual. Let's see. This word is important. Huh? So just after closing the switch, there is no current. In steady state, anyway, current won't flow, isn't it? In steady state, capacitors will be open, so current will anyway flow like this. But he's saying when you just close the switch, for some reason, capacitors are not getting charged. Meaning there is no current in this branch. When capacitors are getting charged, but there is no current flowing like this. Think it's an easy one. It just looks scary though. Let's see. What is the catch in the question? The reason why the current is not flowing through that is simple thing. There must be no potential difference. So this point and this point must have same potential. Since VA is equal to VB, if VA is equal to VB, there'll be no current. So if there's no current, you can treat them. This is one circuit and this is one circuit. So upar na, how will the voltage divide? So let's call this point as. So let's call this thing voltage as V1. This voltage is V2. This voltage is V1 and this voltage is V2. So for resistors in series, how will the voltage divide? V is equal to IR. So V is proportional to R. So the voltage V1 by V2 must divide in the ratio of R1 by R2. For capacitors, both are in series, Q is equal to CV. The voltage will divide in the ratio of 1 by C. So V1 by V2 must divide in the ratio of C2 by C1. Therefore, you can clearly see R1 by R2 must be in the ratio of C2 by C1. So, B option. Clear with that? So in series, the voltage will divide in the opposite ratio for capacitance and this thing. That is the reason A and B ka potential was always same. That's why current will never flow in the ammeter in the middle. Clear? Easy question, not tough, but little different. You see the capacitors and people think like, okay, what the hell? It's more of a shock factor. So hope you guys remember this. We did something like this. I taught you the hexagon wala problem, yeah? This is an infinite grid, but all are triangles. How to do this thing? You should definitely check out the class notes. We have something called principle of superposition. I showed you this with two different varieties though. Did I show in capacitors? Okay? I think I showed this in capacitors. There. So what is the idea in this thing? You don't send current through both of them at the same time. First you send only through A, see how the current split. Send only through B, pull the current from B and see how it splits. And then you take the resultant of these two. So here what we do in this grid, I will not draw everything. I'll just draw one or two circles. So this was A. So what you do, assume current I is flowing through A. By symmetry, we can see the current will split I by 6, I by 6, I by 6, I by 6, and so on, I by 6. And the current will go till infinity. Current is only going through A. So this was B, okay? So if this was A and this was B, let's say you're pulling current out of B. Then again by symmetry, current will come from infinity. That means your second terminal is at infinity and B is the one terminal of the battery. Current will come from I by 6, I by 6, I by 6, and I by 6. So if you send the current and if you pull the current at the same time, so that is if you combine these two, something like this. So this was A. If you send current through I, then you will get I by 6. And if you pull the current from B, then also you'll get I by 6 through the branch. That means in the branch which is connecting A and B, the current flowing is I by 3. So VA minus VB is equal to I by 3 into R. R equivalent is nothing but potential difference by current, which is R by 3. So you can replace this entire grid with a resistance of R by 3. You guys remember this technique? Principle of superposition. Check out the current ka notes, quite an important thing. We did the different varieties though. We did a square ka grid. Remember this thing? Hexagonal grid, honeycomb. Same idea. This is a triangular grid, but the technique is the same thing. You should check it out. Principle of superposition. We don't know what happens if you put a battery between A and B directly. So what we do, we put a battery between A and infinity. So infinity is the second terminal. Then you put a battery between B and infinity. Then when you combine them, infinity becomes a common terminal. The battery is between A and B. Clear with this. So this is the way to handle infinite grids. Let's see a meta bridge question. So those questions will look, tough and all, but if you got the hang of it, you can actually see and answer. Let's get this. You guys remember the correction, this thing error? So what are the end corrections? Remember when you connect that wire, you actually use a little additional wire to connect it. So the lengths are not exactly the measurements which you have. So he's saying X is the standard 10 ohm resistor. The galvanometer shows a null point when tapping the key at 52 centimeters. The end corrections are 1 centimeter and 2 centimeters. So this end correction is 1 centimeter and 2 centimeter. So he's saying the key is showing 52 centimeter. It's a meter bridge. So total length, this guy will be 48 centimeter. Determine the value of X. So the length is actually here 53 and that length is actually 50 centimeters. So X by 53 is equal to 10 by 50. So X will be how much? 53 by 5. That is 10.06 ohms. Clear with that? So the end correction is that extra wire which you used to tie. So it is not actually 52 and 48. There is a 3 centimeter extra wire. Clear with this? Yeah. 10.6 ohm. I think that's an integer. So find the value of K. You can play with that also. Easy question, but little different. That's what I'm saying. It's not about doing all tough questions also. I'm more worried about you guys don't know these terminologies. When I say end correction, you'll think of that one. Which one? Resonance column tube experiment. Let's get this. This is another standard one. It's a good question though. Yeah. Yashil Daria got it. Yeah. Let's get this. Let's see. Hope you guys remember this experiment for the internal resistance. So battery, human resistance connected external resistance. Just to draw a circuit, you will see this thing. So battery, internal resistance, and you connect it to a capital R. This is E, I, and this is capital R. So R can be adjusted any value from 0 to this thing. So when do you get 2 amperes? So 2 amperes, meaning it got shorted. The picture will look like this. The potential difference across the battery is 0. Remember, battery is internal resistance. EMF and potential difference are two different things. I hope you remember that. So potential difference VA minus VB is equal to E minus IR. So delta V is equal to minus R into I plus E. Can you look at this equation? It's an equation of straight line. Y is equal to mx plus C. So that intercept is the EMF and the slope is the internal resistance. Are you clear with that? So but you can still calculate here. So this would be E and this would be R. So E by R is 2. Right? And this is the case when there is no resistance only. It's like this open circuit. So here the current is 0 and EMF is 10. So EMF of the battery is 10. Internal resistance is 2. Maximum current will be 2, which can be taken from the battery. Internal resistance of the battery is 2. Clear with this? Good. Next thing. A metal wire has a coefficient of linear expansion alpha. Temperature coefficient of resistivity is rho 2. Apparent temperature coefficient of resistance will be alpha 1, alpha 2 will be small. Always remember that. So you can always use the binomial approximation. This is a little different. Let's see. So what is the resistance formula? Resistance will be rho L by area. Remember, it's a volume thing, isn't it? So rho will be rho into 1 plus resistivity alpha 2 delta T. Length will be L plus 1 plus alpha 1 delta T. Area, whatever is that, that will be A into 1 plus 2 alpha 2 delta alpha 1 delta T. So binomial approximation, when it goes up, this will become rho L by area. That will be 1 plus alpha 2 minus plus alpha 1 minus 2 alpha 1 delta T. All other higher terms are ignored. So therefore, apparent expansion will be alpha 2 minus alpha 1. That's your apparent alpha. You guys are forgetting, even area will change, na? Rho L by A, area also, that's a linear expansion. It will expand in 3-dimensional volume. Clear? So be careful. Not a tough one, but because you only keep thinking about that L, we forget there's an area at the bottom. Something similar on that. This is an easy one. Remember here only temperature quotient or resistance is given, length are not given, so don't worry about that. This is an easier one of the previous case. You'll find similar questions like this. Semiconductor resistance and regular conducting resistance are connected. Find the condition if the resistance value does not change. So because semiconductor will decrease with increase in temperature, conductor will increase. So something of that sort. See. So the resistance series now, so that will be first one will be same resistance initially, same length, same area plus resistivity rho one. Okay. And you can take this thing as R1 plus R2. That would be rho 1 into 1 plus alpha 1 delta T L by A plus rho 2 into 1 plus alpha 2 delta T L by A. That's rho 1 L by A plus rho 2 L by A plus rho 1 alpha 1 plus rho 2 alpha 2. So you don't want it to depend on temperature. So therefore this coefficient has to be 0. So see our option. If for all delta t, this should not change. So rho 1 alpha 1 plus rho 2 alpha 2 must be 0. This is what I was saying. One must be a semiconductor whose alpha is negative, and negative alpha indicates resistance decreases with temperature. This happens with semiconductor. Get them. 2, 4. Temperature quotient of a resistance is this. 300 K, its resistance is 1 ohm. Which temperature resistance becomes 2 ohms? Now, be careful. Remember that formula. It's R is equal to R naught into 1 plus alpha delta T, where R naught is the resistance at 0 Kelvin or 0 degrees. Okay, don't take it directly the 300 from this thing. You can't take R0 as 300. So this will be R300, which is 1 ohm, will be R0 into 1 plus alpha, that is your alpha, and delta T is 300. So from here you'll find R0 ka value. Then you want when the resistance is 2 ohm, so you don't need actually. 2 R0 into 1 plus alpha T. Divide them. Clear? You will get T from here. Actually, no, I think I'm getting a feeling we should take it to Celsius only because this is per Celsius, no? Mm, Then I'll get temperature in Celsius and then convert into this. Which one is giving you the answer?
Kelvin one is better.
Kelvin is giving you the answer. Hmm, Kelvin wala is only giving the answer, yeah. Because उसमें छोटा आएगा number. ठीक है. It actually the units में ना per Celsius or per Kelvin it will become same, I guess. Luckily, so it works out. 1100. What about the next one? 5-volt potential difference is applied across a length 0.1 meter. The drift speed of the electrons is given. Electron density. This is that N. I is equal to NeAVD. Yeah, that N. The resistivity of the material is close to. So let's find the current. I is equal to V by R. And I is nothing but NeAV drift. This is your voltage and resistance is nothing but rho L by area. That area ka term will cancel. I know N ka value, I know E ka value, I know voltage, I know the length, I know drift, I know everything. Get rho from here. Easy? Again, not tough, slightly different from every time it will not be only equations and stuff. Next thing. It's a solid sphere with a cavity. The inner radius is A, outer radius is 2A. The resistivity is given by rho naught into R, where R is between 2A to A. So your resistivity is changing. Let's say you connected this to a battery. This is grounded voltage V and this is grounded. So current is going radially from in to out. Find R equivalent, find the current density J of R, find the electric field E of R, E R, J R, and find drift velocity. as function of r is the distance from the center. Assume n will remain same. N is the number density. Getting it? And if the heat is produced, heat per second per unit volume is proportional to r power x. Find x. We can make this even a better question in thermal conductivity. If I say the inside temperature is K and outside temperature is 2T naught, I can ask you find the temperature between as a function of R. We'll see later on. That would be a really solid equation. There I'll put a thermal conductivity also. There, let's get all of them. This is a good one. This is an advanced paragraph or like more than one choice question or something of that sort. Resistance you are getting in terms of ln. Okay. I think you get in terms of ln. Right. Get everything. I'll give 3-4 minutes and I'll show you. Then you can check your answers. Try. You got 3 minutes. Let's see. At a distance r, take a thin shell. There's one more question I can ask you actually. Find voltage as function of, find the potential as function of x. That's another good one. Meaning this point ka potential is V now, and this surface ka potential is 0. So at a distance r, what will be the potential? That's another good one. I'll give another 1 minute, then I'll show you. You don't need that. You can just take it as n. If you think some information is missing, just add it up. It's okay. Let's see. So take a thin shell. What will be the resistance? The resistance of the thin shell rho, which is rho naught r, length, that will be the dx. I hope you guys remember what is rho L by A, what is L and A. Just don't say length and don't say area. L is the length along the current flow. A is the area perpendicular to the current flow. So when you say that, if you remember that way, it will be easy. dr and 4 pi r square. So resistance will be integrated this. This will be rho naught by 4 pi ln 2. So current is easy. Current is V by R. If you got current, then current density is easy. Current density is simply I by area. Now remember, current is constant. It doesn't matter. Same current will flow through all cross sections. If you got J, then this is easy. Sigma into E. And what is sigma? Sigma is 1 by rho. J by sigma, which is rho into J. But rho itself, rho naught R, and J is I by 4 pi R square. Hope you remember that resistivity is 1 by conductivity. What else I need? Heat per second for this thing. That's a good one. Heat per second by volume. What is heat per second? I square. Resistance of the thin shell, dr. That's the heat produced in the thin shell by volume of the thin shell, which is 4 pi r square d small r. Is that making sense? Heat produced per second by the thin shell by volume of the thin shell. This is the heat per second in thin shell. So whatever heat the thin shell is providing, you have to divide by the volume of the thin shell. I square is anyway constant. dr is this guy, which is rho naught r dr 4 pi r square, and this is 4 pi r square dr goes off. One r will go off, you'll end up with 1 by r cube. Clear with that? There, you can play like that with the volume thing. What about the potential? That's a good one. Potential is, and this question, exact similar question, you can replicate in heat transfer, conduction. Instead of voltages, I'll ask you temperature there. So you want potential difference at a distance somewhere. So let the distance be. You can do this. You know dr ka value. How much is that? Rho naught dr by 4 pi r. So what is the small potential difference? I into dr. Why minus sign? In the direction of current flow, potential will decrease. Integrate on both sides. dV, current is anyway constant, integral rho naught dr by 4 pi r. What are the limits? You are starting from A to some point R. At A, what is the potential? V, and this is some potential VR. V of R. V of R minus V is equal to minus I naught rho by 4 pi. That will be ln R by A. So potential as function of R will be V minus I rho naught by 4 pi ln R by A. This is the potential with the distance R. Clear with this? I hope you're getting why we take minus sign. Negative since potential drops. Signs are important. If you don't take the minus sign, you'll get plus here. That should have given you an alarm like, boss, something went wrong because potential is increasing. You'll not get zero outside. Happens. Generally, we mess up the minus sign, then that's what I'm saying. In the end of the answer, don't blindly just have a look at it. If I got a plus sign, it doesn't make any sense. How can the potential increase as you go out? Outside is zero. That would have given me the clue, boss, I messed up a minus sign. Clear with this? It's a good one. Any doubts on this? You can integrate E dot dr and also get it. That also works. What else I asked you? I asked drift velocity also. वो भी है ना एक. That was fine actually. What is the drift velocity? I is equal to n, which is constant, e, which is constant area, is pi r square into v drift. There, so v drift is also proportional to 1 by r square. So I can actually ask this proportionalities only. The current density is proportional to r, electric field is proportional to what, r power x, and so on. Clear with this? Take a break, come back by 9:40. We'll continue from here. Any doubts so far?
So, can you just explain that graph one where we got the potentials and the internal resistance one? But actually, I kind of missed that.
Check it out. It's there here. Here. Here's this. There, non-ideal batteries, page 94. Check out the notes there. Non-ideal batteries, we have a full description there with examples and all that stuff. Check it out. Still confused? Let me know. Next class we can discuss. Chalo, come back in 5 minutes. There, let's get this. There, all these are RC circuits. This is the current in capacitor. Match then. This is the current in capacitor. This is the time constants. This should cover all RC circuits. And if you know your RC circuits, you can do LR also. Do you remember that second alternate method I taught you, one general solution? If you do the general solution, the time constants also will come. Do you guys remember the process? What was the process? The general solution. The charge on a capacitor will be in the form of Q is equal to A plus B e power minus T by tau. Valid for one capacitor, A and B are constants, T is a time constant. Step 1, how to find the time constant? Replace all batteries with wires. Then find the resistance across the capacitor. So treat the capacitor as two terminals and find R equivalent. Then time constant is R equivalent into C. Step 2, at T is equal to 0, find the initial charge. You'll get one equation. At T infinity, find the final charge. You know how to do that in steady state. You'll get a second equation. Solve, you'll get an answer. Clear with this? Same thing, we can do it in LR also. So try 4 questions. I'll give you 3-4 minutes. First was easy. First one ka time constant is what? RC. Current will be what? E by R, T by CR. So this thing is 2 and P. There I did 1 for you. You do the rest. First one is the standard RC circuit. Second is also easy. I think third would be a good one. Fourth is also easy. Third is a good one. Try. And others do keep your cams on. Let's see. What about the second one? Iska time constant is 3. I'll just get the time constants. This is RC. This is 3RC. 6R and 3R are 2R. So this is 2RC. What about this thing? So let me draw this. How to find time constant? Assume the battery is a wire. Then this will be 6R. Then this is R. Find R equivalent across the battery terminals. So this is 3R, 6R, and R. So you need to find R equivalent across these 2 points. 6R and 3R are in parallel. I hope you can see that. This thing and this thing are in parallel. Same potential difference. That will be 2R, and 2R and R are in series. So this R equivalent will be 3R. Therefore, this time constant is 3RC. I hope I did that right. 6R, 3R, 18 by 2, 3R. Yeah, that looks right, I guess. So this option is not coming anywhere. Okay. And then how do you find the current? First was easy. Second, third, 1 to 4 are easy. I'm not going to do them. You can just do with E minus T by 3RC. Let's do the third one though. For the third one, 6R, R, and C. This is 3R, 6R, and voltage. Perfect. Now, at t is equal to 0, charge is 0. At t infinity, how will the circuit look like? At t infinity, capacitor becomes fully charged, so there will be no current in that branch. This is how the circuit will look. So whatever current is coming from the battery, all the current will flow through this thing only. The current in the capacitor will be 0. So I can find I from here. I will be V by 9R. But this capacitor will have some charge. So let this be plus Q and this will be minus Q. I can apply Kirchhoff's law in this loop. Minus I into 3R. Then I'm going from negative to positive terminal. Q by C is equal to 0. That is how you find charge on the capacitors. Clear with this? You just assume there is no current in that branch, but write your circuit normally. Okay? And then you'll get Q is equal to I into 3R. That will be CV by 3. This is your final charge. All clear with that? So then you're done. So the regular thing, Q is equal to charge on the capacitor is A plus B into e power minus T by tau. So T0, Q is 0. That will be A plus B. At T infinity, Q is CV by 3. That will be A. So B ka value is minus CV by 3. Therefore, the charge on the capacitor is CV by 3, 1 e power minus T. Time constant is 3RC, so minus T by 3RC. You want current, differentiate this. That would be CV by 3 and 1 by 3RC e power minus T by 3RC. That will be V by 9R e power minus T by 3RC. Do we have such kind of option? Proved up somewhere, I guess. Current in the capacitor. Or maybe this is a current in the battery, I suppose. Current in the battery, and that will be. Are the equations right? Did I mess up? They're getting option Q, E by 3R minus T. That only, I got a 9 there. Anyone can find any mistake here? Time constant is right. Charge. Looks right. I think maybe this is not the current in the capacitor, right? It's current in the battery, I guess. If I take current in the battery, then will I get? I need to find capitalized function of time t. That is a little work. Hmm. Okay, I'll check it out. Let's see something else in the meantime. Let's get this bulbs. I hope you remember how to do bulbs. In case you forgot, what does a bulb do exactly? When you say the bulb is 220 volt, 4 watts, it's a rated voltage. The meaning of this is if you apply 220 volts, the bulb will give a power of 4 watts. So power is V square by R. So indirectly, they are giving the resistance of the bulbs. So that is 220 square by 4. That is the meaning of it. It doesn't mean, you can't apply 110 or you can't apply 440. If you put 110 volt also, the bulb will work. The meaning of that is if you give 220, then you get 4 watts. I hope you're clear with that. You try this in the meantime. I'll check the other one where it went wrong. Because in the previous ones, if you see now, in this case, luckily 1, 2, 4, current in the capacitor is current in the battery only. So we didn't have a problem. Only 3 may you are getting that issue. Let's get this. So we have 3 bulbs, 50, 50, 100. All have same rated voltage 200. Bulbs are in different combination. The power consumed in the combination is what? And yeah. Do you guys remember the power ka combination formula? The bulbs work like capacitors. Yeah, they. Let me show you that in case you forgot. There, bulbs in series and bulbs in parallel. If you keep all the bulbs in series, which has a power rating of P1, P2, P3, Pn, then if you keep all in series, then the net power will be 1 by P1 plus 1 by P2 and so on. If you keep bulbs in parallel, then the power adds up. This would be a straightforward question. At a CET level, there is a question like this. But okay, let's see how will you handle this. You can do it normally also. You can actually treat them as R1, R2, R3, and then you can solve. Same story though. But if you know that bulbs behave like batteries, na, it will become easy for you. So इसका power क्या होगा? 1 by P1 plus 1 by P2 plus 1 by P3 is 1 by P equivalent, right? इसके लिए क्या करेंगे? For B1, B2 we'll take 1 by P1 plus 1 by P2. That's your P equivalent. And then in B2S, basically it is like capacitors. The powers will behave like that. So if you know that, it becomes much faster for you to solve. Try. Bulbs are one important model. नहीं, this is right only. Match नहीं हो रहा है. That is not there in the option also, I guess. So Ishil, एक बार check करो ना. See why are you getting V by 3R? But to use principal superposition, there's only one battery, na? If you had multiple batteries, you can use superposition.
You consider the resistance one having zero battery.
So then that would be like if there is zero battery, then capacitor ka charge zero only, na? There'll be no current only due to a zero battery.
Or if we are,
So you're treating here there's a battery, na?
yeah, here and the 6
So
are
think,
and
na? Yes, if there is no battery, then there'll be no current only, right? What is principal superposition? If you have two batteries, V1, V2, put only V1, see what is the current. Put only V2, see what is the current, and then add them, right?
finding the
So,
effective and then the effective part.
but that's what I'm saying. See, when you say V2 battery, then you'll assume V1 is zero. You take one battery at a time. You can't take both. एक बार check करो फिर भी I'll also see once more, but you can actually try it with integration also normally. आ ही रहता with integration also for me. So what to do this thing? So here you can clearly see, since all have same rated voltage, you can clearly see R is proportional to 1 by P, or P is proportional to 1 by R. So if you have bulbs in series, P1, P2, then 1 by P equivalent is 1 by P1 plus 1 by P2. If you have in parallel, then P equivalent is P1 plus P2. This will make your life easy actually. So just to calculate the resistances, R1 will be voltage square, V square by 50. R2 is also same. R3 will be V square by 100. So for convenience, if I take R1, R2 is 2R, and then R3 will be R. So basically this is R, and 2R, and 2R, and this is R. Okay? Now ask yourself, all three are in series, same current is flowing. What is the power in the bulb? I square R, right? Which will be bigger? B1, B2, na? So in the first case, B1 and B2 will glow brightest. So this will be R. And what will be the net power? You can calculate now. So 1 by P equivalent will be 1 by 50, 1 by 50 plus 1 by 100. How much is that? 1 by 25 plus 1 by 100. So P equivalent will be multiply 4, 5, 20, 20 watts. Second option now. And who will glow brightest? B1 and B2. Clear? Can you finish all the rest? I'll give another minute or two. So that's it. Once you know this, it will not take much time to solve now. But the brightness thing you have to check though. So here all three are in parallel. So if all are in parallel, P is equal to, so whoever has more rating will glow more, right? So B3 will glow more. Power to will add up 200 watts. ये second वाला easy था. Get 3 and 4. Let's see. What about the B3? That guy will be 1 by P1. B1, B2 both are 50-50 now. So they will act like 25. That is 25 and this is 100. So this is 125. And who will glow the brightest? B3 only. Because B1, B2 with the voltage will become 100. B3 has full voltage 200 and the wattage also is 100 watts. That was fine. B1, B3, 50, 100. 50 into 100 by 150, 53, 100 by 3. B1, B3 parallel, they'll add up actually. 150 and 50. For the 37.5 watts. Who will be the brightest? You have to check actually here. So it's like 2R, R, and this is the circuit, and current I is coming here. So current will split in the opposite ratio. So this guy will be I by 3, and this guy will be 2I by 3, and this guy will be I. So power P1 will be I by I square by 9 2R. Power in second bulb will be I square R. This is also 2R. Power in 3 will be 4I square by 9 into R. P2 is bigger. B2 will glow the brightest. Clear? How am I checking? All three are in series, na? Let the current go. What we want is only the ratio. We don't want the exact values anyway. But do remember this, powers you can directly add them up like scalars, like the capacitors. That will save you a lot of time. If you try to do normal, it will take a lot of time. At a mains level, they'll simply give you a straightforward thing. They'll put 3 bulbs in series and they'll just ask you the power. Don't add the power. Be careful there. That's a bulb is a good one. In case you forgot, now you remember. Let's get this ammeter ka thing. Ammeter is in the 50 ohms, full scale deflection, used as a voltmeter, as a higher range ammeter. 4 options. Check. This will take care of ammeter and voltmeter ka questions. You have to check all 4 options independently. Luckily, actually, you have to check only one option. If you put 200, see whether 10 or 30. If you put 50, see whether it is 1 or 0.1. You have to check only 2 options. There, just substitute in the formula, you get the answer. Let's see. So you want to use this as an ammeter. So this is your RG. The value is there, 50 ohms. IG is 50 microamperes. So capital I will be, this is the formula for ammeter, Ig plus 1 plus Rg by R shunt. See, the moment there's an ammeter, now you should remember the formula. If you don't remember the formula, you're late. Mains mein, they're not going to ask you something out of the world. It will be straightforward questions. Voltage will be Ig into Rg plus RL. The formula should just come out naturally. Getting it? Then you'll be able to handle these questions in less than a minute. You will have time. You can finish all the paper fast. And because you need that same kind of speed for bits also and other exams also. Advanced is only exam where you get little more time. So you're done. Substitute everything, then you'll get the answer. You want to see the current there? You have to check Ig will be 50 microampere. 50 into 10 to minus 6, 1 plus Rg. You're keeping 50 in parallel. So that's, our galvanometer is 50 and 50. So if I use 50 and 50, both are 50, interesting. That will be coming out to be 2, that's 100. So that's 0.1 milliampere. These answer right. This is 50 into 10 power minus 6. 200 kilo ohms is much, much bigger. You can ignore that Rg there. So that is 200 into 10 power 3. That is 5 to 10. I think 10 volt is the answer. Clear? Kuch nahi tha question mein. If you know the formula, substitute, you'll get the answer. That's what I'm saying. You should remember your formulas and stuff. This is a good one, right? This is a conceptually good question. Let's see. Think, take a minute or two. This is a worthy question. When you read the question, how do you guys read this question? You know how I read? So if I'm reading the question, parallel plate capacitor, dielectric slab, K, 1/3, C1, plate covered. I didn't understand the question actually. You're getting it? I'm just skipping the words. I'm just reading it. Then I look at the picture. Then I look at the options. So I got some idea roughly, like, he's talking about there's a capacitor, it is partially filled and everything. So you want the fields and everything. Okay. Now I'll read the question properly. The first time when you see it, just glance the question. Matlab, just try to pick up the important words and just glance. Normally, when I do that, I won't take more than 7, 8 seconds or 10 seconds maximum. I'll just glance the question. I just got a rough idea, but I don't know what is being asked properly yet. Second time I'll read it. Parallel plate capacitor, dielectric slip constant K between the plates. 1/3 of the area is filled. Okay, so this must be A by 3. Now I'll start putting the data there. 2A by 3. Total capacitance is C, while the portion with the dielectric, this is C1, and the niche ka, and the capacitor is charged, the plates covered by the area dielectric, this guy gets Q1, that's guy Q2, electric field, the dielectric is E1, and this is E2. Okay, now I understood what is being asked. So you have to read the question at least twice. Getting it? You still didn't understand, read one more time. There's nothing wrong. Question has to be read 2 to 3 times. The problem, you guys think I'll read once and I'll understand. That's not going to happen. You will mess up most of the times. Always, and remember, options are part of the question. Always look at the option. Just don't read the question, because when you look at the options, you'll understand what is being asked, right? Do I want to find capacitance or charge or field? So he's talking about these 3 things. So your mind will be able to connect, what is my end point? So when you're thinking, your brain will have a navigating point, like, where you have to go. If you don't see the options, you'll be lost, like, okay, exactly what am I supposed to find? So always look at the options. Options are part of the question. So you have big questions, 4, 5 lines, 7 lines, 10 lines. Just first glance it, 10, 15 seconds glance, and then read it again. Your brain will get a context. That's how you actually read books also. When you read a book which is very difficult, and let's say you have to read 100 pages, I do that only. First, I'll read maybe first 2-3 pages, then I will flip the page randomly here, there, there. Maybe I'll see the context. If you see the headers now, I'll read the headers. You'll get a rough idea like what you're going to read about. Then start reading. Now your brain has a idea. Okay, this is going to happen next. This is important because once I checked it out, it's like in a paper of 3 hours, people spend 45 minutes reading the questions. You spend that much time reading the questions. Almost 1/3. So if you don't read properly, you're going to goof up things. Anyway, so how do we do this? Capacitance is easy, that you can find. The electric field is what I'm more interested in. Try. I'll give a minute more. Red Puraja, you got it. Let's see. First thing, let's look at the electric field. I don't even need to know anything about the question. What is electric field? Potential difference between the plates by distance between the plates. Whether you have dielectric or whether you don't have dielectric, it doesn't matter. Are you clear? Isn't that the question we did in capacitor? Where was that? ये वाला question याद है? So if you see, when you kept a dielectric slab and the potential was maintained, right, and this was there, it didn't matter. The potential difference remained same. So what is happening? I'll tell you. See, let's say you keep a direct empty capacitor, okay, and you keep a battery V. Okay, so what will happen? This will get a charge Q, which is CV, right? And this is the electric field between the plates, and this is minus Q. We know electric field between the plates is given by sigma by epsilon. Sigma is nothing but Q by A epsilon, right? And Q is CV. So this was the formula there, okay? Great. Now when you put a dielectric slab, capacitance of the system has become Kc. Now the charge has become KCV. Getting it? That's your new charge, Q dash. Now because of this, in this region, we'll get a field E. I'll call it E dash. This region, the field is E dash, where E dash is Q dash by A epsilon. That is true. So actually the field has increased by how many times? That has increased by, this is KQ. The field actually increased by KE times. That is between the space, okay, in the empty space. And but what is the field inside the dielectric slab? Whatever is the field outside by K, na? In the dielectric slab, the field will drop again. So E dash by K will become again E only. Are you getting what happened? Because you kept a dielectric slab, charge increased. But inside a dielectric slab, the field will decrease. So both will get cancelled. You'll get the same field end of the day. Clear what happened? But if they ask you this question, if there is an empty space here, what is the field between that little empty space? That will increase. But inside the slab, it won't. Now here in this case, you know what happens? So first of all, I'll just put that down. So E is equal to V by D. No discussion. Matlab, you have dielectric, no dielectric, it works. Second thing, then what is the catch? This side and this side, you won't have same charge. So here, because you have a dielectric, you will have more charge. Let's call it sigma 1. Here you'll have less charge. Here it will be sigma 2. So sigma 1 will be greater than sigma 2. How do I know that? You can actually simply split this into two capacitors, right? Same voltage. Just now we saw the charge will actually increase on the surface. So that will have more charge there. So you can split it. So they didn't ask you that question, but sigma 1 is greater than sigma 2. You can play with that also. Clear with that? And what about the capacitance? Initially, the capacitance was parallel plate capacitor within the plates covering 1/3 of the plate. The total capacitance of the capacitor is C, while that of the portion of the dielectric between is C1. Okay, so C1 will be K times A by 3 epsilon by D. And what about C? C is nothing but both the parts, K A by 3 epsilon by D, and the other is vacuum, so 2A by 3 epsilon by D. Got this? Both are in parallel, no? They have the same potential difference. You're done. Substitute there, you get the D answer. Are you clear with this? So in this case, they will not have same charge distribution. They'll have non-uniform distribution. So if I draw the picture again, this will be more concentrated. This will be less concentrated. Keep that in mind. You get non-uniform distribution. This is another good one. This can be asked in 4 different things. I can ask this thing in capacitors. I can ask this thing in viscosity, Poiseuille's equation. I can ask this thing in thermal conduction. I can ask this in current. 4 chapters. The V-shaped thing. Let's get this. Junction law. This is what I'm saying. The moment you see the question, you should know what you're supposed to do. Junction law. That much idea you should get. Now start solving. Let's get this. How do you start? If this guy is V, this point will be V plus 6. This guy will be V minus 10. This guy will be V plus 8. I know picture is a little this, but that's a negative terminal. Let this current be I1. Let the current be I2, and let this current be I3. We know I1 plus I2 plus I3 is 0. What is I1? Potential difference across the resistor, which is V minus 10 minus 20 by 2. What is I2? V plus 6 minus of minus 15 by 1 plus V plus 8, that is grounded. So minus 0 by, I think that is R, I guess. Picture is not clear, equal to 0. Solve, we'll get the answer from here. Clear with that? You can handle that much. I'll leave it to you. 44 by 7, it seems. Yeah, that's your answer. Then check it out. Looks scary, but That's how you handle these kind of things. Junction law saves you a lot of time. All clear with this? Let's get these two. ना आदित्य, do the first one ना, do the tough one ना रे. जो easy है वो खत्म करके you are happy about it. Truly ना, you are that kid who goes to the pizza, hut or Domino's pizza, पूरा toppings खा के बाकी छोड़ देंगे. There was one of my idiot friend like that. He used to go to KFC. He's like, we'll share equally करके. He used to eat all that outer layer and then he used to leave the other part. उसको पकड़ के इतना मारते थे ना हम. So how to do this thing? Look at the first one. This thing we can see 5, 3, 140. ठीक है, we actually know everything. देखो ना, this is 40 volts and this is 20. Current goes from higher to lower, so current must be flowing this way, and 40 by 20 is 2 ampere. If that is 8 and 2, then this must be 10 ampere. Perfect. So this is also 2 ampere. Oh yeah, na? I can just apply junction law here and I'll get this thing. So 100, across that the potential will be minus 40 and then minus 10 into R, and then I'll come back through this. That is minus 2 into 10 and you're back. That would be 100 minus 40, 60 minus 20, 40. R is 4 ohms. Clear with that? This information was crucial. That the voltage across that was 40 volts and 20 ohms. Here, what is the answer? 0. You can see and tell why. I hope you remember this thing. If you send a current through a battery, it has to come back to the battery, right? So this has to be I1. If this guy sends I2, then this has to come back to the battery again. So by chance, if the current goes into the 2 ohms, right, then there is no way for the current to come back again, isn't it? I hope you remember this thing. This is also an important one. We did have a discussion on this. That was a good question, though. There, same question, say. We wrote it in detail. Current in this branch has to be 0. If that is not 0, then the current entering a battery and leaving a battery will not be equal. Clear? That's a pretty good question. Matlab, not tough. You can, if you know, that's what I'm saying. If you have seen this, you will just mark and go ahead. Saves you time in the exam. This is another important one. Let's see कितना लोग को याद है. Post office box. Remember, I told you how to do this thing, how to do these kind of things. If you remember post office box, in case you don't remember, please go and check it out. There are actually 3 resistors here. Remember these plugs, when you close that plug and open the plug, you're actually changing the resistances. So between A and B, this is one resistor. Between B and C, there is one resistor. And between C and D, we have one more resistor, isn't it? So you already have 3 resistors. So we have to keep the unknown resistor. So when you get this kind of question, just draw them. You will see that clearly. A to B, there is one resistor. B to C, there is one. And there is a D. So A to B, there is one resistor. That is this big guy. B to C, there is one resistor. I'll put that in green. C to D, there is one resistor. I'll put that in blue. So circuit aisa hai. Now you tell me, where will you keep the unknown resistor? The only thing is left here, na? This will leave the unknown resistor. They can ask this question also. Where will you keep the battery? Now here there are 2 answers, okay? Here the battery, you can keep the battery between A and C, or you can keep the battery between B and D. Battery and galvanometer are interchangeable. Remember the statement? So here you keep the galvanometer, or here you can keep the galvanometer. Both are acceptable. So in a Wheatstone bridge, if you interchange the battery and the galvanometer, it still works. Clear? So unknown thing. So if they ask you where is the battery, where is the galvanometer, there are 2 answers. So check it out. Is that clear, everyone? Post office box is a meta bridge, so be careful with this. So when you see post office box, think of like this. Just put 4 terminals and just try to arrange them. It can be A and D2. How can you put a battery between A and D, right? Then where will you get the Wheatstone bridge? You forgot, yeah, Wheatstone it should be always across this, right? You can't put it like that. It won't be balanced. Check करके देखो. You'll not get a resistor like that.
I
ये
didn't know
एक
you
और
were asking
important.
for Wheatstone.
Post office box is a Wheatstone bridge, right? Go check out the notes. It's important. I got questions. Basically, when we say meta bridge, na, post office box, there was a big story I told actually. What happens if a wire is cut, blah, blah, blah. And we had a story in the class about post office box and stuff. Check out the notes once. It's important. Current is a very important chapter, has a pretty good weightage. It's like rotational mechanics. I wouldn't say rotational mechanics. It's like kind of like our work per energy in mechanics. EMI is like rotational mechanics. Remember this formula? Mixed bridge. Kya tha formula? Series, parallel. There are 2 formulas there. Again, if you forgot, we did this thing in grouping of cells, mixed grouping. ये पूरा derivation था. There I told you how to mug up the results. N is equal to root over NR by small r. N is the total number of batteries. R is the external resistance and small r is the internal resistance. Clear? Important one, very important question. Even I have a problem remembering this result. I to derive it. But you figure it out. I get confused between this N and M. Which is N, which is M. Sometimes I get confused. So, like I said, when I was in 12th, I had this policy. If I can derive something in less than 45 seconds, I won't remember it. There is one question I wanted to ask actually. Where is that guy? This one. Let's finish up with this. This is the last one. I was searching for this only. Potentiometer. Anyone remembers half deflection galvanometer method? क्या था half deflection galvanometer method? Don't remember only. And the third one याद है? Figure of merit. कहाँ पे गया था figure of merit? वो याद है? Magnetism, moving coil galvanometer. Construction of moving coil galvanometer. I told you it will come. Finish off the first one. I'll show you the remaining two. The potentiometer cell gives a balance point of 75. This cell is now replaced by another cell of unknown EMF. If the ratio of the two EMFs of the cell is respectively 3 and 2, the difference in the balance on the potentiometer will be. So in potentiometer, if you remember, you guys should definitely go through the current thing. It's okay if you forgot today, right? Check it out, this thing. Post office box, how it looks, what is the concept, everything you should check. Forgetting is completely fine, but after this, what are you going to do? Go and revise that. That is the main catch there. There, if you remember, in order to find the EX, this was the result. The EX is proportional to X proportionality. And I taught you also. This is how the actual experiment goes. We take two cells, E1 and E2. First, you keep them together. Then E1 plus E2 is proportional to L1. Then you put them in the reverse. We get E1 by E2 is proportional to L2. And then you divide them and you get it. This is how the experiment is actually conducted in the lab. You use the proportionality. Now from that, if you see the question for the first one, so the EMF EX is proportional to the length. So he's saying initially it is balanced at 75 centimeters. So E1 is proportional to 75. E2 will be proportional to some length L. And he's saying so E1 by E2 is 3 by 2. So that will be 75 by L. So L will be 50 centimeters. He's asking the difference in length. So that is L minus 50. So difference will be 25 centimeters. Is that clear? Easy? But you should know that E is proportional to X. We'll catch that. If you don't remember, then it will take time. Now, what is this 1/3 deflection method? Let me show you the half deflection, then I'll show you how to do this. If you there. What is this half deflection method? It's an experiment to find the resistance of galvanometer. How does this experiment work? First, you take the galvanometer, put it in series to a resistance and a battery. You get some current, V by R plus G. Then what you do, you put a shunt resistance S. And this S ka value can be adjusted. So mostly you'll put a rheostat there. So you keep adjusting the value of S such that the current in the galvanometer should become half of the previous value. Because if you keep changing the value of S, the current in the galvanometer will keep decreasing. At some point, the current in the galvanometer becomes half. That's why it is called half deflection method. The deflection in the galvanometer becomes half. Now in our question, it is mentioned 1/3 deflection method means current has become I by 3. Got till here? That is the main thing you should know. Once you know that, it is simply a current electricity equation. Now what is the circuit ka question? S and R are in G are in parallel. Find the R equivalent, then divide by the current, and it is given Ig is I by 2. So substitute and solve. So you end up with this result. So the resistance of the galvanometer is that external resistance R into shunt resistance by R minus S. Clear with this? The same thing when you do for 1/3, here you will keep this as 1 by 3. So in our question, so this will be 1/3 of the previous value, and this will be Ig will be 1 by 3. And Ig ka value, how will you split? That will be I into S by S plus G. Agreed? So substitute that thing and solve, you will get the answer. So when you do that now, you will end up with something like G minus 2S in the denominator. So this B will be the answer. 1/3 differential can be used in G is equal to twice the equal to shunt resistance. So we can check out that. What about this figure of merit? Anyone remember what is figure of merit? It came in magnetism. Moving coil galvanometer. Yes. Figure of merit is nothing but galvanometer constant, which is current per deflection theta. I hope you remember this derivation there. I am not able to copy the whole thing. Yeah, it's not giving the whole thing. What the hell is this? ठीक है, this is the figure of merit. Check it out. Moving coil galvanometer experiment. It's in magnetism. So what is he asking you? He's saying that if n represents the actual number of deflections, then the total number of current is what? So this is I by theta. So that would be how much? K by NAB. Actually, I'm not in the converted galvanometer of resistance G and the shunt resistance S. And the total current I when its figure of merit is K. So basically, figure of merit is something but current per angle. Number of deflections in a converted galvanometer. This is only n, right? Or theta by is n. Let's say if there are, it's a total angle theta, and let's say number of deflections are 0.1, 0.2, 0.3, that will be n into each division will give you the total angle. I need to check this out, I guess. Is the number of actual, basically n is the number of divisions. Total current IG by each angle subtended. I think this is only n, I guess. Total current is I. This is n. And what is the total current I? Ig 1 plus Rg, which is G plus S. Chalo, let me check this out. I think if I do this, I'm getting confused between that I and capital I. Because this thing actually measures small ag. Capital I is n theta. So I think you'll get G plus S by S. कुछ तो confusion है ये. Let me check this out. Next class we'll discuss in detail. चलो ठीक है. That was one. I think it's 1 by theta only. ठीक है. We'll discuss about next class inverse tan 45. There, that is a few things about this. I'm sure some of you forgot something, so go and revise that, right? Especially the instruments and everything. There, we did some decent number of problems today. So check it out. So Monday when we catch up, we will start off with fluid mechanics and properties of matter. So properties of matter is again elasticity, surface tension, viscosity, and fluid mechanics, dynamics and statics. So we have 2 classes for that. And as usual, Monday we'll also have a speed test after that thing. So do plan for it accordingly. Okay, with that we'll wrap up for the day. So any doubts, anything else, stay back and ask, or else you're free to leave. I'll see you Monday at 6 o'clock. So take care, stay safe.